Hello everyone. This video we're going to talk about how to get chess notations like E4, E5, the the language used in chess, and then convert it into a format which robot can understand, so that we can give in our inputs, and that would take that, understand it, and then move the robot. That's what I'm going to talk about and how I implement it in the existing robot. So basically the motivation here is to get like an input, which is a chess notation. Here suppose we have d4, which is moving the pawn from d2 to d4. How do we take that and then translate it so that the robot moves to the start position and the end position? So in order to do this, I broke it down into nodes and topics, which are like the fundamental building blocks in ROS, and using which I made up this setup so that we could publish a chess notation onto the chess notation topic. And this is like a string. So we publish d4, and then this d4, uh, this what the value which is published on this topic is subscribed by this robot service. And what it does is that it converts this chess notation, and then it creates into a start pose and an end pose. So now we have start pose and an end pose. We can convert get that into a list, that is the start pose and the end pose, into one list, and then we publish it onto the post topic in the form of a geometry message called pose array. And from this topic we subscribe this value, whatever is being published here, by this post receiver. And what this does is that it takes this input, converts that, uh, gets takes this input, and then it asks move it to move to the desired locations. So uh, the heart of the whole thing comes under this robot service node, and what this does is broken down here. This node has basically a callback function which is called upon whenever something is published onto the topic here, which is the chess notation topic. Whenever it is published here, what this does is that it receives whatever is published. So, as in the case like E4, if it's published there, it takes that, and then it uses some sub functions in the program, which you can see in the GitHub. Um, what it does is that it uses that and then converts that E4 into the starting square and ending square. This is called UCI notation, which is used for the chess engine to work. So in order to get from here to here, we use a library called chess python library, and that does the job for us by getting this uh, string notation in the beginning to this string, which is e2 e4, which makes more value because it says where to start and where to end. Now we know e2 e4, that is in the chess coordinates. We need to bring that to the actual world coordinates, as in the xyz position for the robot to move. So in order to do this, we already have an idea of how much each square length is on the chessboard, and where the starting point of the chess board is. That is the A1 point on the chessboard. So here we utilize these dimensions, these uh, units, the basic units, and then we pass this into E2, E4 into two bits, that is like E2 and E4. These are two squares. And then when we take this particular E2 out, we extract uh, the value for e in the sense how much it has to move in the x-axis. For example, if it is b2, we need to move on the x-axis by 1 unit from a1. So we match these values, the alphabetical values to numeric, and we move the x-axis by that amount, and then we use this amount, this value, the 2, as in how much we need to move on the y-axis. So with the basic dimensions of the length of the squares, we can then navigate from this chess coordinates to actual world coordinates. And that's what this function does. And once we have this done for both, that is for E2 and the E4, these are the two, the start square and end square, we take those poses and then we combine them into a list of poses. And we use this message type called pose array, which has a header, a timestamp, and then it has a list of poses. So we add the starting pose and ending pose as a list to this pose array. Once all this is sorted and now we have like a list of poses, we publish this particular list of poses to uh, to our post receiver, which contains all the sub functions for moving the robot. Uh, that is the basic move it tools to command the robot to move to a particular location. So once we have this set of list of poses, what we do is we iterate to them. We iterate to them as in we take the starting pose, we ask the robot to plan for it and then move it, and then again we go to the next end pose and then we plan it and then move to that particular pose. So this is how I went about setting this up, and some of the fundamental things which were used were the Python chess library, which you should look into. This is the link, which says how do you convert basic chess notations to uh, the UCI format, which will be helpful for the chess engine interface. And then just looking up into how pose array is, how it's defined, gives you an understanding of the entire structure of it and how you can utilize it to send your data from one particular node to another. And then understanding of basic nodes, subscriber and publisher. Uh, these are like the fundamental concepts which you need to understand to do any ROS project, and this was very useful for doing the whole thing. With all this said, uh, I was able to get from a notation, just notation, and then uh, command it, get the robot to move to those locations using that. So the main motive of this is that now we can give arbitrary inputs and get the robot to move. This would be like the first step before we interface a chess engine to that, so that the chess engine, the machine learning AI tool, will generate the, the coordinates, and then we can command the robot to move it. So getting this pipeline set up will help us to integrate the chess engine so that we could say start this getting this whole chess playing robot to start playing with itself, like get it to move, get the chess engine to move for white and then ask it to think for black, and then so we can do this as the next step, and that's what I plan to do next. Thank you everyone and have a great day.